my name is Audrey Rubart, and this summer I worked at Sandia National Laboratories. This presentation is for EC 3990. So a little bit about me. I'm a senior in electrical engineering, and I'm getting an honored electrical engineering degree. My interests are in microwave engineering and electromagnetics. And currently I'm actually working with Dr. Simpson doing some research using finite difference time domain methods, or FDTD. The reason why I kind of got into this program is because I've always had an interest in radios and then the electromagnetic spectrum. I would love to learn about DM spectrum in my physics high school classes. And when I learned that essentially radios use the EM spectrum to communicate, it just kind of all came together to me, and it's kind of nerdy, but I think radios are super cool. So it's kind of where that passion came from, and it was like a really cool, once I figured out that electrical engineering did this kind of stuff, it was pretty much the only thing I wanted to do. From this summer, I actually don't have any pictures, and there's a couple of reasons for that. The first being that everything I worked on is considered OUO, or official use only. That's something that the Department of Energy called anything that's sensitive, but it's not necessarily classified. So while it's not classified, it could still, what they call damage national security if I were to talk in some of the details about it. So I have to be kind of generic about what I talk about today. The other reason is I worked from home this summer because of COVID-19. I was originally supposed to move down to Albuquerque, New Mexico, but because of the pandemic, I was asked to stay here in Salt Lake City, so I worked completely remotely. But I did get a cool t-shirt, so check out my shirt. So the program itself, so there's kind of a hierarchy to it. And so so there's internships and then intern institutes. And so I was a part of an intern institute. Essentially, the institute was just, you got an extra manager, there was extra support for you. And then also I got to go to like a lot of tech talks during the week. So I got to go to 1 or 2 tech talks a week, which was pretty awesome. TIE-IN stands for the Technical Internship to Advance National Security. And then within TIE-INs, I was a part of a program called MSTIC. And MSTIC stands for Monitoring Systems and Technology Intern Center. So within MSTIC, I was just kind of with other interns doing similar projects that I was working on. And then underneath MSTIC, I had my projects. So I had 3 main projects this summer. One of them was an ITC project, a database project, and an antenna project. Again, it is official use only, so I kind of have to be very generic in what I'm talking about. So for the first project, I worked on I2C stuff. There's kind of 2 parts to this project. The first one was I oversaw I2C addressing, and so on our board we have different sensors, and we need to be able to communicate that with a microcontroller. And so you do that by setting addresses for these different components, and then we have to make sure that we're not setting the address the same for multiple sensors. And so I communicated that to my team using a Git wiki. The other part of my project was doing a state of health class, and so in C++. And so essentially on the same sensors, we want to know the voltages and the currents and the temperature of everything that is running on the board, and just to make sure it's running properly, we're not getting too high of currents and the temperature is not overheating the board, stuff like that. Second project I worked on, I used a lot of third-party softwares. One of them was Prometheus, and Prometheus is a time series databasing tool. Essentially, you can scrape and send data to Prometheus, and it'll timestamp it for you and kind of hold it for you, and then you can send that to Grafana, and Grafana is a really cool way to graph your data in a cool, very stylized way almost, and so it's very easy for the user to understand what's going on. And so I pretty much tried to send the data to Grafana to show my team what they needed to see. So they had a custom-made RF operating system, and they wanted to see when they run their software tests where they were running into memory leaks or CPU spikes. And so the point of Grafana was to kind of show those graphically so they can kind of look at it the next day and be like, oh, we need to go back and fix this part of the software test. The last project I'm calling my antenna project. I didn't work on anything technical, but I still got to do a lot of cool things. I was paired with an antenna engineer. He gave me just advice about the field itself, as well as some grad school advice. Within working with him, I kind of learned about constraints that exist with electrically small antennas. And I also learned about angle of arrival techniques. So essentially, you can use an antenna to figure out the direction a signal is coming from. And I also learned 2 really cool softwares, one of which is HFSS. HFSS is a antenna design software system, and it's used really commonly throughout industry. And then Quux, and Quux is very similar to Keysight's ADS program, but it's a free version of it in a very lightweight Windows executable file, so it's really easy to use on pretty much any system. So that was kind of cool to learn that program as well. Overall verdict, I decided that Sandia National Labs is probably not for me, but I would recommend it to others. I found the work really challenging and very interesting, but I realized I don't want to move to Albuquerque, New Mexico, and I also didn't love what I was working on kind of like what I mentioned earlier, I'm really interested in microwave engineering or antenna design, and pretty much all I worked on this summer was coding or digital engineering. So it wasn't quite the right fit for me, but I would recommend this to others. Yeah, that concludes my presentation. I really appreciate your time today. Thank you.